see what we got going on here. So lesson 1.4, there is, if I turn that on, then it works. There we go. So there's a few bits of vocabulary here. Polygon, side, vertex. You've heard me use that word before. Vertex, n-gon, convex, and concave. Okay, so polygons, poly means many. So polygons means many-sided figure. So it could be, so polygons includes triangles, it includes four-sided figures called quadrilaterals, 5 sides, 6, however many sides you want. Now we have some specific names. I've got a little chart over here. 3 sides is a triangle, 4 sides is quadrilateral, 5 sides is a pentagon, but they can't have infinite number of names of the things. So that's what n-gon is about. If it's a 14-sided thing, it's a 14-gon. If it's a 17-sided thing, it's a 17-gon. That way we can make the names as we need them. Now they also show here. Let me clear my drawing and move up a little bit. Oop. Okay, that is not helpful. There we go. There we go. Ah, you are annoying. There. That's better. Okay. All right. So they also have these two ideas of convex versus concave. So see how this one has a side where the line of the side goes through it? That's one way of thinking of what concave means. So notice none of these lines go through the interior, but this one does. I like the simple mnemonic of a concaved polygon is caved in. See how it's like smushed in here? So concave is caved in. So this one's concave, right? Because it's caved in here, but this one's not. This one's convex. Convex is the other one. All right, let's clear the screen and wait. Look at the next stuff here. Oh, I need to turn the page. Okay. So now we're talking about, oh, let me move this up a little bit before I do that. That's right. All right, there is the concept of finding area and perimeter in the coordinate plane. Of course, we've got formulas for finding area and perimeter, right? Notice perimeter just means to add up all the sides. Don't get too caught up in formulas for it. They're not worth remembering unless they're worth looking up, but they're not worth remembering. These 3 sides, we add them up. The square, the reason why the perimeter of this is 4s is because there's 4 sides that are all the same. You could also go s plus s plus s plus s, same diff. Rectangle, it has 2 sides of the same, and these 2 sides are the same. That's why it's 2 lengths plus 2 widths. That gives you 2 of these guys and 2 of these guys. If you're finding if you're having to find the perimeter in a coordinate plane, Notice two of the sides. Okay, so this one side right here, we definitely have to use the distance formula. That's what we did in the last section, right? We used the distance formula. We can use the distance formula here. These sides, though, technically you can use the distance formula, but what would have happened when we did the distance formula here? See how the y's are the same? If we were doing the distance formula, we'd have -2 minus 3 squared plus -3 minus -3 squared. This part just ends up being 0. So the long and the short of it is, once I do this, that's like -5 squared and then square rooted. Those guys undo each other, except that it ends up making it positive. So they're just kind of skipping ahead and going, look, if the lines are on the vertical or the horizontal, you're just going to use what they call the ruler form, the ruler postulate, and just look at the difference between the two of them, because it's right along. See how you can use the grid as a ruler? I'm not worried about the -2 and -2. The distance between 3 and -3 is 6. Right? That's what they did right there. And also, frankly, you can count the squares, right? If it happens to be graphed, 1, 2, 3, 4, 5, 6. Remember, we're counting the squares, not the lines. So once you find the 3 sides, they added it up. Yeah, I think I have to click. Okay. Literally. All right. So, oh, God dang it, now you can't see. Oh, so annoying. You need to see the picture. Yes, there we go. All right, now we can do it. All right, so finding area in the coordinate plane. Now, when we're finding area of a triangle, we don't need to find all of the sides. What we need, because remember the area formula is 1/2 base times height. We just need a base and a height. Well, this length is really easy to find, right? Because we don't have to worry about squaring and square rooting and all that. It's just that we're going from -4 to +4. This distance is 8. So it makes sense to use this as our base, and then our height is this right here, this length, which I can see by looking is 6. All right, the distance between, this is at -3 and this is at +3, that's 6. So then I just go ahead and do it. 1/2, base is 8, height is 6, half of 48 is 24. There we go, and that'd be done. And they're just explaining what I just did there. All right, what else do we need to look at? Oh, okay. Let me get to the top here, and then I'll clear off all my own notes. Okay. Okay, we got a little word problem here. You're building a shed in your backyard. The diagram shows the 4 vertices of the shed. Vertices means corners. Find the area of the floor of the shed. Well, that's easy. We use the ruler postulate. If you're going from 2,2 to 2,7, it's the absolute value of 7 minus 2, which is 5. Also, of course, since it's graph, we could count the squares, right? See, 1, 2, 3, 4, 5. We're going from 2,2 to 8,2, so that's the value of 2 minus 8, which is 6. Now I've got a rectangle. I can multiply length times width. The area is length times width. So the length is 6 and the width is 5. So that's 30. Now I'll check my units. Each unit represents 1 foot, so this would be square feet. That's how I tell.